Imagine waking up one morning and knowing that an earthquake will strike your city at 3:14 p.m. sharp. Buildings could be evacuated, lives could be saved. But here's the truth. Despite decades of research and billions in technology, scientists still can't predict earthquakes with precision. And this is why. Earthquakes happen when stress builds up in the Earth's crust until rocks suddenly slip along a fault line, releasing massive amounts of energy. The science of this process, plate tectonics, is well understood. We know where earthquakes are most likely to happen, along places like the San Andreas Fault in California or the Pacific Ring of Fire. But knowing exactly when one will strike, that's far more complicated. One major reason is that the Earth's crust is incredibly complex. Stress doesn't build up evenly. Rocks twist, bend, and fracture in unpredictable ways. Two sections of a fault might look nearly identical, but one could rupture tomorrow while the other holds steady for centuries. Scientists have searched for reliable warning signs, changes in groundwater chemistry, strange animal behavior, even foreshocks, smaller quakes that sometimes happen before the big one. But the problem is consistency. Sometimes foreshocks happen, sometimes they don't. Sometimes animals react, sometimes they don't. No signal has ever proven reliable enough to serve as a true prediction. In the 1970s, China claimed to have successfully predicted the Haicheng earthquake after noticing unusual foreshocks and evacuating a city. But just a year later, another major quake hit Tangshan with no warning at all, killing hundreds of thousands. That failure showed just how dangerous relying on uncertain predictions can be. Instead of predictions, scientists focus on probabilities. Using seismic records, they estimate the chances of a big quake striking a given region within decades. For example, California's U.S. Geological Survey says there's about a 72% chance of a magnitude 6.7 or higher quake hitting the San Francisco Bay Area before 2043. That helps with building codes and emergency planning, but it doesn't help you on any given Tuesday afternoon. Technology has given us some progress, but only in the form of early warning systems. In places like Japan and Mexico, sensors detect the first seismic waves underground and send alerts before the stronger shaking arrives. The warning time is short, often just a few seconds, but those seconds can be enough to stop trains, shut down gas lines, or allow people to take cover. Still, it's not prediction, it's reaction. The truth is, predicting earthquakes would require monitoring every fault line deep underground with incredible precision, something we're nowhere near capable of today. Earth is simply too vast, too messy, and too dynamic for us to read its every move. So for now, earthquakes remain sudden, destructive, and largely unpredictable. Scientists can tell us where the risks are highest, they can build better warning systems, and they can prepare us for the inevitable. But they cannot say, tomorrow, here, at this time. And this is why we can't predict earthquakes.